My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 548. In this lecture, we will try to understand activation functions. Now, let's revisit what types of activation functions are more useful in neural network. So, between 1980s, let me say, between 1980s almost in 1990s, even in early 2000s, there are two activation functions which are extremely popular. By the way, activation functions are these functions that you have FIJs, that you have that each of the neuron computes. So the most popular in pre deep learning era of neural network have been the sigmoid activation, the sigmoid activation function, and tanh function. There are two activation functions. One is sigmoid activation function and another one is tanh function. Let me explain sigmoid activation unit. In my next lecture, I will discuss about tanh function. Let's assume I have an activation unit here. Let me say this is my activation unit. This is my activation unit. Let's assume I have an activation unit here. Let's call it as Fij. What is this activation function? Fij with some input weights. What are my some input weights? W1, W2, W3, W4, isn't it? I have inputs. What is input? X1, X2, X3. I can say X4. And let's assume when I multiply Wixi and sum it, just I am taking sum it them, this is equivalent to, what is this? This is W transpose X. What is my W? W is a column vector W1, W2, W3, W4, X, X1, X2, so on, X3. Isn't it? That is W. This is essentially, I can say, W transpose X, where X is also a vector, W is also a vector. The input to Fij, what is my input to Fij? The input to Fij is weighted sum. Let's call the input is Z. Let me assume this Z is input to this Fij. What is my Z? Z equal to, what is my Z? Z equal to sigma I equal to 1 to 4 Wixi, isn't it? That is my Z. What does it mean? What is my this one? Weighted summation. W1 x1 sigma means summation W2 x2 W3 x3 W4 x4. That is my Z, isn't it? What is the output here? I am giving input Z for this one. Therefore, my output is Fij. This is my output. Fij of Z. This I can say my output. And what is your Fij? This Fij is sigmoid function. Fij is sigmoid function, isn't it? I can represent it as sigma, isn't it? That is sigmoid. This Fij is sigmoid unit. Let's represent sigmoid unit with sigmoid function. I can represent with sign sigma sign. So the sigmoid unit says, what is my sigmoid unit? Sigmoid unit is essentially e power z. What is this? Your sigmoid of z equal to e power z by 1 plus e power z, which is equal to 1 by 1 plus e power minus z. How will I get this one? Just I am dividing with e power z in numerator as well as denominator, so that I will get 1 by 1 plus e power minus z. And if you recall our logistic regression, this is nothing but what we use in logistic regression. Sigma is exactly the sigmoid function that we used in logistic regression, and one of the most popular activation function in the olden days. Remember, what are the requirements? What are the requirements of activation function? It needs to be differentiable, and it should be easy to differentiate. You might wonder why are we taking this complex function sigma z equal to 1 by 1 plus e power minus z from differentiation perspective, sigma has some advantages. Okay, let's see. What is my sigma of z? 1 by 1 plus e power minus z. What is my z? My z is equal to W transpose X. Fij of z is nothing but, here Fij of z is nothing but sigma of z. Fij of z is nothing but sigma of z. Here Fij is sigmoid function. Very interesting thing that you have here is what is the derivative of sigma with respect to z. That is important. Derivative of sigma with respect to z. If you compute this derivative, what will you get is interesting. That is sigma z into 1 minus sigma z. The most important part here, the derivative of sigmoid, the derivative of sigmoid function is represented in terms of sigmoid function itself. If you implement this, if you implement sigmoid function called sigmoid of z, let me say, if I implement a function called sigmoid of z, you write some code. Let's say you write the code to compute 1 by 1 plus e power minus z. This function that you write here can be used. This function can be used. This function that you write, this function here can be used in forward propagation and as well as in computing derivatives, isn't it? We compute derivatives during the back propagation stage to update your weights, because the derivative of sigmoid is expressed in terms of sigmoid itself. So if you implement one sigmoid function, you can reuse it for both for forward propagation as well as for computing derivatives in backward propagation. Again, it is not the only reason. Again, there is a nice blog that I refer to. Just go through this blog. Very, very nice blog. So this is how sigmoid function looks like, and it goes from minus infinity to plus infinity, and the maximum value is 1 and minimum value is 0. The minimum value is 0, maximum value is 1. We saw this plot in lot of detail in logistic regression. We discussed this works as a squashing function. So this is what sigmoid looks like, and there is a nice detailed explanation of how to compute derivative of sigmoid function. Let me say, there is a nice explanation in this blog. Of course, this is not that visible. I request all of you to refer this blog. Just I wrote here, I am assuming 1 by 1 plus e power minus z. This is sigmoid function. If I differentiate a with respect to z, I will get a into 1 minus a, isn't it? Just you can go through this one. Sometimes sigmoid function is usually represented with the symbol, with the sign sigma of z, which is instead of here I must write standard notation is sigma of z. Dou sigma of z by dou z is sigma z into 1 minus sigma z, isn't it? Now that just it's a simple intermediate differentiation. Anybody can understand. This is a, I am assuming this 1 plus e power minus z, I am assuming g of z. Therefore a equal g of z whole power minus 1. What is my d by dx of x power n? My d by dx of x power n is n into x to the power of n minus 1. Therefore minus 1 into g of z minus 1 whole power minus 1. Again chain rule. By using chain rule, I must differentiate g of z with respect to z. G of z with respect to z means what is g of z? 1 plus e power minus z. Differentiation of constant is 0. Therefore differentiation of 1 is 0. Differentiation of e power d by dx of e power ax means a into e power x, isn't it? D by dx of e power x means, therefore minus 1 into my e power minus z. This will be, what is your ultimately, what will you get here? Your dA by dz is e power minus z by 1 plus e power minus z whole square. This can be written as e power minus z plus 1 minus 1. Just I am separating this one. Yes, what will I get? This is a. this is a square. If I take common a into 1 minus a. Therefore, what you are getting here, your dA by dz equal to a into 1 minus a. That's what it says, isn't it? Anybody can understand this simple differentiation. This is this I can write, I can rewrite like this. If you want, even if you write in sigma symbol, I can write d sigma by dz equal to sigma into 1 minus sigma, isn't it? The derivative, they derived it. This is well written. This is well written blog. Now, how does it look? Just see, how does it look? What is this? How does it look? If blue line is my sigmoid function, this is my sigmoid function. This is my sigmoid function, isn't it? My sigmoid function, minimum value is 0, and maximum value is, sigmoid function maximum value is 1, and it goes from minus infinity to plus infinity, isn't it? If you look at sigmoid, somewhere from minus 4 to plus 4, if you look at this minus 4 to plus 4, it is growing fairly well, but after that it is growing very, very slow. Fall is very, very slow. This is what is this? This is basically derivative of sigmoid function, isn't it? If you notice the derivative of sigmoid maximum value, where can I get maximum value? Here I will get maximum value. This is derivative of sigmoid maximum value. After that, the derivative is extremely small. Derivative basically says how fast sigmoid function changing. The derivative of sigmoid is always less than, I can say here, if I say less than 0.3, less than 0.3, it is always less than 1, and of course always greater than or equal to 0. Less than 1 and always greater than or equal to 0. Therefore, 0 less than or equal to d sigma by dz less than 1. This is very, very important thing. We will see why it is important in next lecture. This is very interesting function. This property of sigmoid 0 less than or equal to d sigma by dz less than 1 has some problem. We will discuss maybe in next lecture, or we will discuss in some lecture after 1 or 2 lectures. But sigmoid is also very popular, as we represent derivative of sigmoid. Sigmoid is represented in sigmoid itself, and sigmoid also fits nicely into the framework of logistic regression that people have been used for many years. So sigmoid is one popular activation unit. There is other popular activation unit called tan H function that I will discuss in my next lecture. That is lecture number 541. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.